All right, let's talk about solving multiple step inequalities. Now again, by multiple step we mean it's not just going to be a simple one step to fix these, but again, they're still not very tricky and difficult. We've solved multiple step equations before. The only real rule to remember about inequalities is whether or not you need to flip the sign. Otherwise, we're going to follow our same rules as equalities. Don't forget to flip the sign if we multiply or divide by a negative number. We're going to use that backwards order of operations, though, our simple steps to solve these. So again, if I'm looking at some multiplication, right, 2 times y, as well as afterwards, then I would be subtracting 5. Well, in order to solve, we're going to start by saying let's add 5 to both sides. 2y minus 5 plus 5, simple order of operations, says that that's 2y. And I'm just that much closer to isolating that y. Because all I did was add, I'm going to leave this sign. And I've got 12 on the right side there. Then we'll simply divide by 2. Now I am dividing, but notice that 2 is a positive number. So again, 2y divided by 2 is just y. Because it was a positive 2 that I divided by, I'm just going to leave that as less than. And 12 over 2 is 6. So that's a good statement for us right there. And again, let's make ourselves a simple number line. By graphing, again, it's only a single variable. So we're just going to say open circle, and we want to be less than 6. Same thing happens over here at the right. Let's subtract 15. Again, looking at our order of operations, here's our variable. Multiplication, again, normally happens before subtraction does. But notice again that subtraction, that negative is also attached to the 3. If it helps you, think about that as plus a negative 3 multiplied by x. I'm really getting rid of addition. I'm getting rid of a positive 15. So I'm going to subtract 15 on both sides. That makes for a negative 3x left over. Again, all I did was subtract, so I'm going to say still less than or equal to, and 12 minus 15 would be negative 3. To get rid of the negative 3 on the left side, over here by the x, well, since it's multiplication, I'm going to go ahead and divide. Make sure I divide on both sides of my inequality. Negative 3 divided by negative 3 leaves me with just that x. Because I divided by a negative 3, I'm now going to flip that sign, right? Instead of less than or equal to, we're going to be greater than or equal to. And negative 3 divided by negative 3 is just 1. Again, that's a simple statement there. And a simple number line to draw. Here's a 1. X is greater than or equal to 1, so solid dot and greater than. That's solving multi-step inequalities. Again, think about what the easiest thing to get rid of would be, right? What's the last operation happening? That's the first one to go. This 15 simply can be subtracted to the other side, or in the first problem, I can simply add 5 to the other side and get that much closer to isolating my variable. Let's try one more here. It's got a little bit more going on. But again, that shouldn't stop us. First thing I notice is on the left, we've got that set of parentheses. So what I'm going to go ahead and do is distribute. 2 times 4n would be 8n, and 2 times negative 1 would be negative 2, or minus 2. Leaves us with 17n plus 9. Now I'm all simplified, right? I've gotten rid of all the parentheses. There's nothing more to do to 8n minus 2. I can't do anything with 17n plus 9. However, I do notice I've got variables on both sides. I've got an n on the left and I've got an n on the right. So I'm going to go ahead and subtract 17n. There was a positive 17n, so I'm going to subtract 17n. I'm going to get these like terms together. 8n minus 17n is a negative 9n. I still have that negative 2 sitting over there. Again, all I did was subtract, so I'm just going to say greater than still. My 17n's will cancel and leave me with just that 9. Now it looks a lot like the problems from the first page, so let's add 2, leaving us with negative 9n greater than 11, and divide by negative 9. We don't get a pretty answer there, but again, oops, not an equation. I divided by negative 9, which means I need to flip that sign. Greater than becomes less than. And again, 9 doesn't go into 11, so I'm just going to leave that as a negative 11 ninths. You could find that 2 and 2 ninths or 2.2 repeating. But again, that's simple enough. I'm just going to say that this is negative 11 ninths on my number line. Open circle. And again, we're less than. So we're going to the left. Let's take a quick look at a word problem or how these might tie into the real world. You plan to publish an online newsletter that reports the results of a mountain bike competition. Your fixed monthly costs are $1,200. Now, fixed cost, remember, that means it's just a simple $1,200, not multiplied by the months or anything. That's a one-time thing. You must also pay $130 per month, right, per month to each writer. You do not want your monthly costs to exceed $2,370. Well, it's not the number of months that's a problem. It's actually how many writers do we want to hire, right? How many writers can you afford to hire in a month? So let's let X equal the number of writers, while Y equals the total cost. I'm already spending $1,200. I'm also going to add on $130 per writer. Sounds like a Y equals MX plus B kind of idea, right? $130 per month to each writer, per writer. So again, that sounds like a slope. Now my total money, again, isn't to exceed, right? I can't exceed $2,370. So I need that money to end up being less than, right, my total cost. Well, my total cost, right, is $2,370. So I need that to be less than $2,370. And now I can't exceed that, but that doesn't mean I can't equal that, right? So I'm just going to leave that there. Let's go ahead and solve. Subtract 1,200 on both sides. And we get 130x is less than or equal to, again, all we did was subtract. So that's going to be less than or equal to 1170. Now let's divide by 130. And x, again, we divided by a positive number, so still is less than or equal to. And I believe, well, we might need our calculator for that one. So let's go ahead and turn on our calculator. You know, it's definitely not 10. I'm thinking maybe 9. 9 sounds like a good answer to that one. But let's turn that calculator on. 1170 divided by 130. Clear off what's on here. 1170 divided by 130. Enter. And sure enough, comes out as a simple 9. Now, notice they didn't ask us to graph this time, but it is a word problem. So how many writers can you afford to hire in a month? I would say less than or equal to 9 writers. You could say no more than 9 writers. There's lots of ways to word that statement. But again, we don't want any more than 9 writers. X is less than or equal to 9. And of course, we want to heed our elders' words here. Make sure you're wearing your helmet if you're riding your bike up that hill there. All right. One final statement. We got a couple last statements here. We also want to be very careful with inequalities. Remember, there were ways with equations to have no solution or infinite solutions. How would that look with inequalities? So let's go ahead and take a look. If we take this 2 and distribute, right, and then we do a little bit of work, you'll notice that we can have inequalities, again, where our variables disappear. I would subtract those two t's so I can combine those like terms, which means that -6 is greater than -8. Well, now that's a true statement. If I think about a number line, -6, right, again, -8 is less than that, which means -6 greater than -8 is true all the time. Well, that means that our inequality will be true all the time. And our best answer there is all real numbers. Or what we often represent as that capital R, sort of with that double bar on the side, right? all real numbers. Notice on the problem over here, let's go ahead and follow through on this one. I'm going to distribute. 3/4 of 8 is 6. And again, 3/4 of 4 would be 3. Still greater than. I'm also going to distribute on this side. This would be a -3 plus 6n. Again, if I subtract my n's to try to combine like terms, well, I get rid of the 6n's on the left, but I accidentally also get rid of the 6n's on the right. And is -3 greater than -3? Well, never, right? -3 without the equal sign. Is it greater than itself? Well, no, which means this one would be no solutions. Be careful. Again, if your variables disappear, make sure that your statements can still be true. If they're still true, then it's an all real numbers answer. Any t would make that true. If they're not, then it's no solution. Make sure you talk to your teacher if you have any questions. Otherwise, have a great day.